Hi friends, today I'll be explaining physics, October-November 2015, paper 32. Question 1 states a comet traveling in space enters the atmosphere of a planet. Figure 1.1 is the time speed graph for the comet from time is equal to 0 seconds. So this is the speed time graph from 31, 32, 33, 34, 36,000 meters per second in 12 seconds time. So part A, part 1 state during the period t is equal to 0 seconds to t is equal to 6 seconds, both the speed of the comet and the velocity of the comet remain constant. State what this suggests about the motion of the comet. So the answer will be the comet is moving at constant velocity in straight line. Then part 2 states determine the distance traveled during the period t is equal to 0 seconds to t is equal to 6 seconds. So we will use the formula d is equal to speed times time, and from the speed times graph the speed is 36,000 meters per second. So we will write 36,000 meters per second multiplied by the time, which is 6 seconds. From 0 to 6 seconds will be 6 seconds. So the answer will be 216,000 meters. So the distance traveled during that period from 0 seconds to 6 seconds will be 216,000 meters. Then part B states explain what the graph shows about the motion of the comet during the period t is equal to 6 seconds and t is equal to 10 seconds. So in the graph from t is equal to from here 6 seconds to t is equal to 10 seconds, what is the motion of the comet? So from here onwards till 10 seconds over here the speed is decreasing. So the answer will be it shows that a comet is decelerating because the gradient is negative. So when the speed times graph is sloping downwards, this means that the object is decelerating. So the final answer for question B is it shows that the comet is decelerating because the gradient is negative. Question C states determine the acceleration of the comet at t is equal to 11 seconds. So we will take the time of 10 seconds, the time and speed of at 10 seconds and time at speed at 11 seconds. So over here in this equation we will first use 11 seconds and the speed is 18,000 and at 10 seconds it is 24,000. So we will use the acceleration formula, which is a is equal to delta velocity divided by delta t. So at starting it was 24,000. So 18,000 minus 24,000 divided by 11 minus 10, which will be 6,000 meters per second. So the final answer for question C is 6,000 meters per second. Then in question D states suggest what happens to the comet at t is equal to 12 seconds. The comet stops moving because it reaches the surface of the planet. So this will be the final answer for question D. Question 2 states a student wishes to find the volume of a piece of wood of irregular shape. Her experiment requires the use of a small brass object of mass 200 grams. Calculate the volume of the brass object. The density of the brass is 8.4 grams per centimeter cube. So we'll use the density formula, which is D is equal to m divided by V, whereas we have m value which is 200 grams and density which is 8.4 grams per centimeter cube. So we'll do V is equal to m divided by D, which will be 200 divided by 8.4, and the volume of the brass object is 23.81 centimeter cube. So 21.81 centimeter cube will be the final answer for 2A. Then question B states to find the volume of the piece of wood the student has a measuring cylinder. A supply water and the brass object in A. The piece of wood and the brass object are small enough to be placed in the measuring cylinder. The piece of wood does not sink in water. Suggest why. Because its density is less than water, so it doesn't sink. Then part 2 states describe what the student does to find the volume of the piece of wood, stating stating the measurements that she makes and any calculations required. First, she will put water into the cylinder and measure the volume V1. Over here it will be V1. Then she will add small brass into the beaker and measure the new volume, which will be V2. Then she will tie the piece of wood with brass and submerge it into the beaker containing water. When it settles down at bottom, a new volume is measured, which is V3. Over here V3. We can calculate the volume of V by of piece of wood using formula V is equal to, over here V is equal to V3 minus V2. So from this we will calculate the volume of the wood using the formula. So this will be the final answer. Question 3 states define power. So the definition of power is the rate of doing work is called power. So the formula for power is P is equal to watts divided by time. So this will be the formula for power. Then question 2 states in the following list, tick the two boxes next to the quantities needed to calculate the work done on an object. So the mass of object is not one of the quantities needed to calculate the work done on the object. The first one will be the force acting on the object, because this will help to calculate the work done on an object. Then the speed of the object, this will also not be used. Then acceleration of the object will also be not used, but the distance moved by the object will be used to calculate the work done on an object. So the final answer for part 2 is force acting on the object and the distance moved by the object. Then question B states a lift is in a high building, transports 12 passengers, each of the mass 65 kg, through a vertical height of 150 meters in a time of 46 seconds. Calculate the power needed to transport the passengers through this height. So the formula for power is equal to work done divided by time. So work done is equal to 12 number of passenger multiplied by the mass of each passenger multiplied by the gravitational force, which is 10. So this will be 1 multiplied by 150, because we will calculate the work done through the height of 150 meters. So the answer of work done is 117 and 000. So we will use 1,170,000 work done divided by 64 seconds, which is the time. So the power that is needed is 18,281 watts. So the final answer will be 18,281 watts. Then question 2 states, part 2 states, the lift is driven by an electric motor. State a reason other than the friction why the power supplied by the motor is greater than the power needed to transport the passengers. Because some of the power is changed into heat and sound energy. So because energy is needed to raise the lift, so this will be the final answer, as a greater if 18,281 watts is used, but maybe more watts power is used because some of its power is changed into heat and sound energy. So you can write this or this. Question 4a states a figure 4.1 shows a top view of the tourist vehicle in a game park and two elephants pushing against the vehicle. The two forces indicated are at right angles to each other. So in the space below, draw a scale vector diagram to determine the magnitude of the result force, label two forces implied and resistance, and clearly state the scale you use. So over here it's two elephants are exerting. First one is exerting 4 kilonewtons, and the second elephant is pushing 6 kilonewtons. So we will be using 7.2 ratio to calculate. Here we will be using 1 centimeter is equal to 1000 newtons. So over here in is 6 centimeter for 6000 newtons, because over here if this elephant is exerting 6000 newtons, then divided by 1000 will be 6 centimeters. So 6 centimeters exerted upwards, and then 4 centimeter is exerted towards the right. So when we use the magnitude over here, if we connect these both lines, make a full right triangle rectangle, and we measure this length from bottom left point to the top right point and measure the length, which will be 7.2 centimeters. So when we multiply this by the original what's this original scale, which is 1000 multiplied by 7.2 centimeter, which will be 7200 newtons. So the magnitude of the resultant force is 7200 newtons. So we will write 7200 newtons as the magnitude of resultant force. Question B states figure 4.2 shows another elephant pushing horizontally against a vehicle with a force of 11 kilonewtons at a distance 1.8 meters 1.8 meters above the ground. Point M is the center of the mass of the vehicle. So part 1 states calculate the moment about point A of the force exerted by the elephant. So moment is equal to force times distance, which is force is 1.8 multiply by the force, which is 11 kilonewtons. So 1.8 multiplied by 11,000 newton will be 19,800 newton meters. So the moment for part 1 is 19,800 newton meters. Then part 2 states the mass of the vehicle is 1900 kg and it does not slide when pushed by the elephant. Determine whether the elephant tips the vehicle over. Show your working. So the moment of the weight is 9 force multiplied by distance. So 19,000 force newtons multiplied by 1.25 meters, which will be 24 kilonewton meter. So the conclusion is that the elephant does not tip the vehicle over, because over here the moment of about a point A of the force exerted by the elephant is 90,800 newton meters, and over here the moment of weight is 19,000 newton meters. So the elephant does not tip the vehicle over. So this will be the final conclusion for part 2. Question 5a states X and Y are liquid in glass thermometers. The scale of each thermometer starts at 0 degrees. X has a large range, good linearity and high sensitivity, but Y has a small range, poor linearity and low sensitivity. Explain what is meant by the difference of the ranges. So the part 1 answer is it can measure a large range in temperature, and then part 2 states the difference in their linearities. The scales are not equally divided, so X may have a larger difference between each scale, whereas Y has a smaller range between each line. So question 3 states the difference in their sensitivities. The answer is it can measure small change in temperature. So X can measure small change in temperature, whereas Y cannot because it has a low sensitivity. Then question B states a thermocouple is used to measure the temperature of a small volume of liquid. Draw and label a sketch of the arrangement. So first we will draw a thermocouple thermometer from here into one beaker, which is a hot junction, and then in between we have a thermocouple, and then on the other side we have the cold junction in which we have ice cubes. Then we will connect these both junctions with a copper wire, and we will mark this as copper, and then we will write this wire iron because we have used iron wire in from hot junction to the thermocouple, and then from thermocouple to the cold junction, and we will state each beaker of which type it is. Over here on left side we have the hot junction, and on right side we have the cold junction. So this is what we will draw and label a sketch of the arrangement. Then part 2 states the temperature of the liquid is changing rapidly. Explain why the thermocouple is able to respond quickly to this rapid change. Because it is very sensitive. So the answer will be because it is very sensitive, as thermocouple can measure small change in temperature quickly as compared to normal thermometers. So question 6a states in the space below, draw a simple label diagram of the apparatus used to demonstrate Brownian motion. So in a simple label diagram, we will first draw a glass box with double layer, and then inside we will make large circles which will be labeled as smoke particle, and around it first on right side we will put four small circles, and on one side we will put a one small circle, and like this we will draw a couple of these, and the small circles are labeled as air particles. So in Brownian motion we also have a lamp which is kept outside the box and directed towards the glass box, and so we will draw a lamp over here, and this will be the simple label diagram for the Brownian motion. Then question B states state what is observed. It is observed that air particles are smaller and faster, so more the number of air particles on one side will push the smoke particles in the direction of force of air particles. Then question C states explain what is observed in terms of molecules. So smaller molecules are faster and light in weight, whereas large molecules are slower and heavier in weight. So the question states what is observed in terms of molecules. So we will write this answer as the final answer. So in this we will have 2 marks. Question 7 states sound from a loudspeaker is traveling in air towards a solid wall. Figure 7 shows the compression of the incident sound wave and the direction of travel of the wave. So part A states state what is meant by compression. So compression is a region where particles are closer together, which is called compression. So this will be the final answer for part A. Then part B states the distance from point P to point Q is 8.5 meters. It takes 25 milliseconds for the compression at point at P to reach Q. So for this sound wave, determine the wavelength. So the formula for wavelength is over here. Wavelength is equal to, what's this, T divided by wavelength divided by the time, which is 25 seconds But over here in the diagram, in 25 seconds there are 1, 2, 3, 4, 5 waves formed. So we will divide 25 divided by 5, which will be 5. So we will write t divided by t, which will be 8.5 divided by 5, which will be 1.7 meters. So the wavelength is 1.7 meters. Then part 2 states the frequency. Determine the frequency. So the formula for frequency is V is equal to D divided by T, which is 8.5 divided by the time it takes to create 5 waves, which is 25 milliseconds. So we will convert this into seconds, which is 0.025 seconds. So 8.5 divided by 0.025, which will be 340 hertz. Or then we will divide hertz, not hertz, it will be the velocity. So we will use F is equal to V divided by wavelength, which is 340 divided by 1.5, which is 200 hertz. So the value of the frequency in this wave is 200 hertz. Then in question C states, as it strikes the wall, the sound reflects, complete to show the position of 3 compression of the reflected sound wave. So over here, when the sound waves are traveling towards the wall, it hits the wall, and then there's a compression of the reflected sound wave. So we will first make a direction of the waves in which it will travel. If it travels towards the wall, then it will move upwards. So this will be the first wave, then this will be the second wave or the compression, and then this will be the third compression. And so these 3 lines will be drawn as the final answer for question C. Question D states, the loudspeaker is immersed in water where it continues to produce sound of the same frequency. State and explain how the wavelength of the sound wave in water compares with the wavelength in BI. So the wavelength is greater because the change of speed is related to change of wavelength. So as water is denser, so the speed will decrease and the wavelength the wavelength will be greater. So this will be the final answer for question D. Question 8a states, figure 8.1 is a ray diagram of a convex lens being used as a magnifying glass to produce a virtual image. So on figure 8.1, label the object O. So we will label the object O, which is over here, and we will mark this as O. Then part 2 states, label the image I. So the image, if the object is close to the magnifying lens glass, so the image will be produced at the same side of object of this where the object is placed. So the image will be over here, so we'll mark this as I. Then part 3 states, label a principal focus F. So where the object rays or the lens rays are intersecting the surface will be the point where the focal length will be, principal focus will be. So we will mark this as F. And then question 4 states, put arrows on the 2 rays to indicate their direction. So the rays will be coming from below the surface towards the object and the image. So we will put one arrow over here and then other one over here. So this is how we will mark the object and the image and principal focus and arrows on the 2 rays to indicate their direction. Question B states, figure 8.2 shows a ray of light in air incident on an interface with glass. The refractive index of the glass is 1.5. So this is an incident ray from the air towards the glass. Then on figure 8.2, accurately draw the ray as it travels in the glass. You will need to take a measurement from 8.2 and carry out an appropriate calculation. Show your working. So we will use first we will measure the angle of the incident ray with the middle line over here, which is 35 degrees. Then we will use a formula which is n is equal to sine I divided by sine r, in which we have to calculate the value of sine r. So we will move r on the left and right. R is equal to sine inverse brackets open sine I divided by n brackets closed. So the value of n is also mentioned in the question, which is the refractive index of the glass is 1.5. So we will use sine inverse brackets open sine 35 divided by 1.5 brackets closed, which will be 22.5 degrees. So we will measure the angle 22.5 degrees over here and draw a straight line that is intersecting the glass and air towards the right side. So this will be the line that will be drawn as adjacent refractive ray. So 22.5 will be the final 22.5 will be the final angle for the refractive index. Question 9a states figure 9.1 shows the symbol for a logic gate. So this is one of the logic gates, and then I state part 1 states state name of this gate. So this gate is a combination of AND gate and a NOT gate. So when these both are combined, which will be this gate, so this will be a NAND gate. So the name of this gate will be NAND gate. Then part 2 states figure 9.1 clearly on figure 9.1 clearly label an input and an output. So on the left side it will be input and on the right side it will be an output. Then part B states in the space below draw a symbol for a fuse. So for a fuse there will be a straight line from left to right and then a rectangle which will be in the middle of the straight line, and this will be a fuse. Then question C states figure 9.2 shows a circuit. So this is a circuit. Component A is not emitting light. It only emits light when the PD across it is greater than 1 volt. The change to the environment around component B causes component A to emit light. So state the environmental change. So in this we have to the temperature decreases for it to cause the component A to emit light. So as we have it states that this is a circuit with a component A is not emitting light. It emits light when PD across it is greater than 1 volt. So this is what's this light resistor. So when there's temperature resistor, so when there's a less decrease in temperature, then this will cause the component A to emit light. So we have to decrease the temperature to cause the component A to emit light. Question 2 states explain your answer to I. So as the temperature decreases, the resistance of B increases, so the voltage of midpoint left to the left of LED increases. Midpoint left of the LED increases. As the voltage increases, more current flows through the LED and it glows up. So the final explanation for this question is that when the temperature is decreased, the resistance in the B will increase, so voltage of the midpoint left of the towards the LED increases. So as the voltage increases, more current flows through the LED and it glows. So this will be the final answer for part 2. Then question D states the combined resistance of the two resistors shown in figure 9.3 is 4 ohms. Calculate the resistance of the resistor R. So the To calculate the combined resistance, the formula is R is equal to R1 multiplied by R2 divided by R1 plus R2. So we have the R1, we will mark this as R1 and this as R2. So we have R1, so 6 multiplied by X divided by 6 plus X, which will be over here 6X, and we will move X plus 6 over there, multiply it, which will be 4X plus 24 is equal to 6X. Then over here we will do 6X minus 4X will be 2X is equal to 24. Then the value of X is 12. So the resistance or R2 is 12 ohms. So this is how we will calculate the resistance of R using the resistance of the first resistor, which is 6 ohms. Question 10a states figure 10.1 shows the gap between the N pole and the S pole of a magnet. The magnetic field in the gap is uniform. On figure 10.1, draw 4 field lines to show the pattern and direction of the magnetic field in the gap. So figure 10.2 shows a horizontal copper wire PQ between the two opposite magnetic poles. So first we will draw lines from north to south, two curved lines, and then two straight lines from north to south. And then, as you know, that the forces are moving from north to south, so we will mark arrows from north to south towards pointing towards the south, so like this. So this is how we will draw the magnetic field, 4 field lines to show the pattern and direction of the magnetic field in the gap. Then part B states figure 10.2 shows a horizontal copper wire PQ between two opposite magnetic poles. So here is a copper wire PQ between north and south. Then a circuit is made by connecting a sensitive digital ammeter between P and Q. The wire PQ is then moved vertically downwards. State and explain what is observed on the ammeter. So the copper wire is moved vertically over here, vertically downwards. So when it is moved downwards, what happens to the ammeter is the ammeter deflects and gives a reading. So the ammeter at starting it's at neutral. Then when the copper wire is moved downwards vertically, the ammeter will deflect and it will give a reading. So this will be the answer for part 1 of question B. Then part 2 state what is observed on the ammeter when PQ is moved vertically downwards at a greater speed. More deflection and the current increases because it is moving downwards. Then question 2 states vertically upwards at the same speed as in 1. It will be more deflection, but the current is reversed. So we will write in 1 more deflection and current increases, whereas in 2 it is more deflection and the current is reversed. So this is what we will write in question 1 and question 2. Question 11a states the counter of radiation detector placed close to the radiative source gives a count rate of 1600 counts per second. The half-life of the source is 1 week. Ignoring background radiation, calculate the count rate. So in first question states 1 week after the first measurement. So after 1 week the radiative source has a half-life. So we will do this 1600 divided by 2, which will be 800 counts per second. So we'll write over here the count rate is 800 counts per second. Then question 3 states 3 weeks after the first measurement. So at first measurement we have 1600, then at second we have half, which is 800, then at third we have 400, which is half of 800, and then at After 3 weeks, we have 200 counts per second, which is because at starting we have 16, then after 1 week we have 800, after second week we have 400, and after third week or 3 weeks after the first measurement we have 200 counts per second. So the count rate after 3 weeks after the first measurement is 200 counts per second. Then question B states figure 11.1 shows the arrangement for an experiment to investigate the shielding of radioactive sources, position of the samples, then thick card, 5 mm steel and 20 centimeter lead. Then samples containing 3 different radioactive sources are placed at one at a time in the positions shown. The table shows the count rates when a radiation detector is placed at the positions A to E. Complete the table to indicate whether alpha, beta or Y rays are emitted from each sample. So sample 1 at A it's high. For 3 samples it's high, but at B 1 and 2 is high but 3 is 0. Then at C sample 1 is high but sample 2 is low. Then at D sample 1 is still high but sample 2 is 0. Then at E sample 1 is low and sample 2 and 3 are both 0. So this means first we will see which one of these are alpha particles. So at alpha particles are stopped by a thick card. So this means that at B, before B it's at 0. So here sample 3 will be alpha particles. Then at sample 2 it had stopped at C. So this means that sample 2 is beta particles, and then sample 1 which is still continuously going on, but at E it's the radiation is low. So so gamma rays or Y rays is at sample 1. So sample 1 is gamma rays or Y rays, then sample 2 is beta rays, and then sample 3 is alpha. Then question C states which type of the radiation A, B or Y is the most strongly ionizing. A is the most strongly ionizing because in such a short distance it can ionize most of the particles. So alpha particle is most strongly ionizing. So this will be the final answer for question C.